Hello. Hello. Hey, how's it going? Hello, everyone. We're gonna do a quick little stream. We've got it's only enough time for lunch because then I have to jump into another meeting. We're doing back-to-back meetings today, and I will have time to go live a little bit later today, a little bit later on the afternoon on my time to do maybe a little bit more time. But I figured might as well give some time right now to stream for just a smidgen, That's a word. It recognizes it. Smidgen is a word. There we go. Like that. There's this one thing I really want to look at right now is this right here. We've got a divide by zero warning, which obviously you don't want that. You can't divide by zero because it's infinity, right? So I need to figure out where this is happening. It's very likely it's happening in the sigmoid because we've got a division here that occurs right here. So it might be in our activation function. And so I'm very curious. I'm very curious to see where it's at. Where is it? So it might be. So what I'm going to do is we're going to comment that out really quick. And we found this because of our, we've got some MNIST training data here. And it turns out it actually works. It actually works. We just have some warnings and some overflows of some sort. So check this out. It's actually kind of cool. So here we go. Let me see if I can. So we'll rerun it here. It loads the MNIST data set, and then it pairs it down because we also need to do batching. Then it runs through a whole bunch of epochs, and then look, it learns the data. So you can see all these NP truths. I want to turn these NP truths into like check marks. Actually, that would be really nice. Just from a visualization perspective, it's a lot nicer to see check marks, but you can see all the output is in the right format. You can see it's completely in the right format. So we're seeing good. We're seeing good news. Oh no, I closed it. I closed it. All right. Python ml.py. There we go. So it works nice. Actually, I want to do that really quick. I want to do that. Let's see here. Let's see that. Okay. But the problem is here's where the problem where it comes in. Wait. Is it gone? No, it can't be gone. It's right here. Here it is. Okay. So we see here on the screen. This is also what I want to try to fix. Divide by zero encountered. Hey, Lokesh, professional. How's it going? Welcome on in. Happy to have you here. We're doing some Python machine learning, and we have this problem with our NumPy. NumPy library is very nice. It helps us a lot. We wrote our own machine learning language from scratch. It's a deep learning neural network, and we ran into a problem. Divide by zero encountered in matrix multiplication. And here's the line of code where it occurs. It's happening right here. And so I want to see warning overflow encountered in matmulp. So maybe we can figure it out. I tried to see if I could figure out what it is, but basically what we need to do is we need to print it. We need to print it. So what I want to do is we'll probably reduce the data set size to 1. We'll reduce data set size to 1. So when we load this, it's not going to overwhelm us with a whole bunch of outcomes and results. Okay. So we get our loss here. We should probably reduce the rate of the loss output as well, because what I want to do is I need to see what the data is in the. So here's our initial weights. Weights look good. The weights look perfectly fine. But hold on. You're new B gamer. How's it going? You new B? Hey, how are you today? We're doing good, B gamer. We're doing very good. Thank you. We are. Hey, Mohammed, how's it going? Welcome on in. We're gonna find a bug. We got to find a bug. We got to find a bug. The bug is right here. Well, the problem is we're running into some overflows. So you can see here on the screen. This is where the problems are. Invalid encountered in matrix multiplication. Overflow encountered, and also divide by zero. So we need to figure out where is this happening. Is it maybe overflow is okay because we're exceeding the range of the bit depth of the floating point numbers. I mean, because you get to a certain resolution, it's fine. So maybe we could not bother with it. But divide by zero, that seems like a problem. That one seems like a problem to me. And so we have these initial weights, and this could be a problem here. But you know what? Let's go over here real quick. I need to reduce the output so that way we can target. We need to target our input. Here we go. 1 second. We need to target our input. And so where is our learning at? Okay, so print loss. So if I mod 100 equals 0, there we go. So that way we reduce that output. So it makes it a little bit cleaner. See, now we can see. That's a lot better. Okay. So initial weight's so good. What else can we print out? What else can we print out? So our delta maybe we can print out the delta. So print delta. So let's see what this is. Print delta. There we go. Let's see if that looks good. What else can we print out? We don't need to print out the loss, but we could print out the gradients. We could put out the gradients. Okay. So print gradient. There we go. Let's print that out. All right. Hey, Skyline, how often do you do these videos? It's so useful. Every weekday. We're doing every weekday. And right now, I only have a little bit of time, so I might have about maybe 20 minutes, and then I have to jump back to a meeting. But I wanted to do this really quick to see if we had a possibility to find where the problem is. And I know like the whole goal of this. I achieved this goal. So we achieved this goal over the last few streams. The goal was build a machine learning framework from scratch without using any other frameworks other than NumPy. We did that. You see here on the screen, we do have TensorFlow, but we're only using it to load the MNIST data set because it is just an easy mechanism. Hello, sir. How's it going, Raj? Raj, welcome on in. We're looking for a bug. We have a bug in the system, you guys. We have a bug in the system. Where is it at? We need to find it. And so, we built this. We were successful in building our own deep learning neural network live on stream, and that's right here. You can see it right here. It's only about 100. It's less than 100 lines. It works really good, and I'm so happy about it. I'm very satisfied. We did it, you guys. We did it, and it works very well. It even works with the MNIST data set, which we found out yesterday. But the problem is we ran into an issue, and there's some sort of clipping that's occurring, and here's the error. We need to fix this. Oh, wow. That's a lot of... Ooh, that's a lot of output. That is a lot of output. There's so many deltas. What's going on? So many deltas. Here we go. Question mark, Matt Mole. There we go. Question mark, matrix molt. Here we go. Here's the errors. Mr. Lamb, hey, how's it going? Good evening, sir. How do you do today? We do well. We're currently on a lunch break with a very big meeting that's occurring, and I figured I would stream right now because might as well stream, and then we will see if we can fix this bug here. So here's the bug. We need to fix this. Help me fix this, you guys. We have a divide by zero. We could probably find that. Hey, Raj, yesterday I created a model using random forest regressor, and the R2 score was negative 1.754. Wait, and you're crying, and that sounds like a problem? That sounds like it's a problem, Raj. What do you want the score to be? What does R2 score should be? What should R2 score be? What is that? What are you looking for? With random forest regressor, aren't you trying to find common patterns? Are you trying to find like a k-means or a clustering, or what are you looking for? Because you want to be able to find like patterns in the data that sort of group together, so then you can create your own boundaries. Is that kind of what's going on here? All right. Oh, good. You couldn't see that. There's something that showed up on my screen. I'm like, oh no, you because I'm like, and I'm also, if you didn't know this, I'm actually, between 0 and 1 is what you want, 0 and 1, but negative 1.75, that is not what you want. You definitely don't want that. That sounds like, okay, so Raj, okay, gotcha. That sounds like a much better range. There was something that showed up on my screen just now. I'm like, because I actually am in another meeting, but I muted myself. So I was predicting the recycling rate. Oh, percentages based on the same features. Oh, that's actually kind of cool. That's kind of a neat idea. Mr. Lim, I have school from tomorrow. Okay, school tomorrow. So I won't be able to attend late night streams anymore. All good. Quite upset on my end. Oh, that's terrible. No. Oh. Well, hey, you always, the VODs are for free. The VODs are free forever. The video on demand, free forever. So if you're ever feeling like you want to not miss anything, well, you can always just catch the recording later. Catch the recording later. Okay, so we need to fix this problem right here. We've got this problem right here. This problem. We need to fix it. Okay, so divide by 0. So we've got a whole bunch of prints here. The deltas look beautiful. I don't see any zeros or any problems at all. So it can't be in the deltas. It does not look like it's in the delta. So we don't need to worry about that. Delta. So we don't need to worry about this. Delta is clean. Delta looks good, but let's see what else we got. What else do we have, you guys? All right, looking at this, we do see quite, well, it's still not overflowing. The gradient looks okay. I mean, it is a it is a pretty small number. If you're looking here, you see these -4s. It just means you're moving 4 decimal places, but that still seems pretty small. I don't see any zeros or anything like that. Gradient looks good. There's a delta, gradient. Looks fine to me. It looks fine to me. What is NumPy talking about? What is NumPy even talking about? It looks completely fine. And this is with one epoch. This is with just one epoch, and the data set size is 1. It's 1 data set size. Is it that it's just too high or too big? Use what kind of features, bro? Wait. Oh, Raj. Actually, that's a good question to Raj. Mohammed is asking you, what kind of features are you using? What features? Which is basically input, right? The input data. The input data, essentially. Features. Okay, so where it looks beautiful. It looks beautiful. It looks perfectly fine. I know if you're here in the stream and you're like, what is all these numbers going? What are all they're really good looking numbers to me. I mean, this is kind of exactly what you want to see. You want to see stuff that looks like this. It looks really good to me. I'm seeing really positive things here. Like these numbers can go up pretty high, like up to -32. Yo, flaming corgis, how's it going? Welcome on back. We're looking for a bug in our code. We see a bug. It's not a terrible bug because the system works. It works perfectly fine. It's just I want everything perfect. I want it to be perfect, and there's these warnings that show up. But it looks like I might have 10 minutes left to find it, and then I have to run. We'll have 10 minutes left. So we're looking. All these numbers look good to me just by sight. All of it looks good. It looks so good because these numbers, they're not too small, but they're not too big. So they're looking good. So where is the problem? Where's the problem, you guys? Mr. Lamb, Mr. Rohit, ask you to reduce the learning rate. Oh, and it worked. Or did it mess it up later on? So it was actually fine. So we could do that, but I don't think so. Here's the learning rate, but let's reduce it. Let's go ahead and reduce it. We'll reduce it down. There we go. We can also reduce the number of epochs. So we'll just do 1 epoch, right? There we go. Okay. Let's rerun it. 1 epoch and a low learning rate. Okay, here we go. Low learning rate. All right. So we do see the warning show up. The warning still shows up. So here's our initial weights. Here's the input data, right? So right here, what you see on the screen, this particular matrix or this array, that's a number. That's the number 5. Can you see it? Can you see the number 5? It's kind of hard to look. You can't see it. But this data right here represents the number 5. It's a handwritten number, and it represents number 5. So it looks good. It looks like, why did the name of the programming language after the snake? Python? Wait, what do you mean? Why did they name, after the snake? I don't know. You ask a really good question, Sankey. Sankey, okay? Sankey, okay? What? Why did I never ask that question? You asked a really great question. Here, let's ask the internet. Why? Let's see what the internet says. Okay, why did they name Python after the snake? Let's find out. Google knows what I mean. I can type it. All right. The programming language Python was named after a British comedy series, Monty Python's Flying Circus. There you go. Is that really the case? Really? That's amazing. Okay. So it's not named after the snake necessarily. It's named after Monty Python's Flying Circus. But is there a Python in why is there actually a snake? Is there actually a snake in Monty Python? There isn't actually a snake in Monty Python, so there's nothing. The programming is named after the show, not the other way around. This is crazy. I never would have thought that. Blue, hey, how's it going? I do have about 10 minutes left, and I got to get going here. But guess what? We're looking for a bug. We're looking for a bug. So everything looks good. There is a bunch of zeros here. This might cause a problem. We might need to do an epsilon. Maybe we were thinking about that. I know, Mr. Lamb, isn't that crazy? Who would have thought? Coolly, Snaky, okay, you got it. I'm squinting and turning my screen upside down, but I still don't see a 5. Oh yeah, yeah. This is a 5. You can't. Don't worry. You can't really. I mean, we could if I shrunk the screen and then here. Let's see if we could. No, that won't work. That won't work. If I printed it differently, you would definitely see it. You would definitely see it if I printed it differently. But no worries. Have you any fine lads seen Monty Python and the Holy Grail? Yes, that was a good one. That's one of like the iconic movies, right? That's one of the iconic Monty Python movies where they have a whole bunch of scenes, and isn't it? Don't they have the Knights That Go Knee, right? The Knights That Go Knee. I think that's the one. I think that's the one. All right. So let's try adding to the input a so now will you think you have to insanely make the text small? Yeah, we will. You're right, the tech man. We would. We'd have to make the text really small and then you'd be able to see it. Actually, can I do that? I can. Wait, let's try it. Okay, let's make the text small. Let's see if that works. Okay. Let's see if we can see the number. Oh, well, I'll have to reprint it. Here we go. Reprinting. Is that going to work? No, it's because it's being wrapped by, it's being wrapped. So you can't see it. But it's basically a number 5. You can't see it right now, but it's basically a number 5. All right, here we go. That looks good. I like that. Is that good enough? Is that good? Can we make it bigger? All right, I think that's good. If this is, okay, there we go. This now it's easy to read for everyone. Okay. I see now. You can kind of see. Yeah, you can kind of see. Just joined. Oh, knee. You got it, Flaming Curries. You got it. So now you reveal, Blum, why was the company named PubNub? Oh, because of PubSub, publish, subscribe. So PubSub it's one letter different, and that's what we do. So we do publish, subscribe. So PubNub, PubSub, basically, is the idea. So we do publish, subscribe, and it's PubSub, but we just changed one letter. It's one letter, and the letter is unique. So that way, when you Google PubNub, you'll only see that name. You'll only see this. And so it was done for SEO purposes and done because it's close to publish, subscribe. It's close to what we do. There you go. You joined. You were implementing character recognition with machine learning. Yes, you got it. The awesome dude guy. You got it. That's what we're doing. The algorithm actually works. It works really well. It works super well. It actually got 100% on the test, on the training data. 100% on the training data. And it works really well. But we need to do batching. And that's something that we'll probably do later today. I do have to get going though to another meeting. It does look like I have maybe 5 minutes left, but we'll see. We'll stay as long as we can. But you're right, the awesome dude guy. That's what we were doing. Let me see. Okay, so I was actually thinking of researching about making Python faster, like C++ or Java. Could you give me views on that? Okay, so Iron Ignat plays Iron. Okay, Iron. Here's what you do. You can create your own compiler. That's what is it? I think it's called C. There's different people have done this different ways. So they actually take the Python language, and then they replace the libraries, the core libraries, with more native C libraries. And then they do call outs to C to optimize. Another one is just in time, where they create all these code execution paths, and they find the best path, but they keep it in memory, and that's PyPy. So PyPy, which is PyPy. So right, so you got PyPy will give you it's like a JIT, but it compiles. Is JIT compiler from Python, but it takes lots of memory. And then you've got what is it called? Iron Python. Right, Iron Python for .NET, and then C Python extensions for C, and you got a whole bunch of different options. So other people have already tried to make Python faster. There's a lot of ways to do it, and then you could also just use the Python language and then compile it down to assembly, and then have an assembler assemble and then link directly, and then you could build that way as well. And that will probably bring Python to the most performance you could ever possibly get. That'll bring Python to a super performance, but it's a lot of work. If you really want to do it. If you really wanna, you could do it that way. What is your opinion on AI takeover? The tech man AI takeover, it's happening right now. Did you know that AI is already good enough to take over basically all of the human work and labor right now? It's already good enough. And so what we have to do in order to achieve that goal is the existing AIs are already smart enough for it. We can leverage something called function calling or tool calling, and then we need to implement and organize how that is orchestrated across the different workflows. And then you can completely automate everything. And that is where we're at right now. The existing AIs are already smart enough to take all of our jobs. The good news is we have to implement the approach to allow them to be in that scenario. So guess what? It's already there. We're already there. All we have to do is just build it and make it happen. That's all we have to do is build it and make it happen. By the way, I have a pet tarantula now. Do you, flaming corgis? That sounds a bit much. Like after tarantula, that is a lot. That is kind of crazy. Oh, let's see if I get some more of the chat messages here. I am trying to get through them. I was actually thinking of researching. Okay, he's made faster. XG boost. The negative R2 sometimes caused by non-correlated features. Oh. Yeah, feature pollution. So when you're building your own AI from scratch, you have to give it training data. And this is the features, right? The input information or the training data. You can often give the model data that has no meaning or purpose. And it's just a whole bunch of noise. And so if you train the model on just too much noise and a whole bunch of just junk data will cause your model to have problems. And that's what Muhammad is describing. Non-correlated data, basically just random noise of data. And so you need to design, when you're designing your AI model, thank you for the likes, you guys, or the reactions. Thank you for the reactions. You will find that you need to spend as much time on the data set and then processing the data yourself and preparing the data as you do the actual model. In fact, you might even spend more time on processing the data ahead because you need to do a lot of things to clean up the data. And the data needs to be represented in a vector to the AI because it only understands numbers. It only understands numbers. Thank you for the likes, you guys. Thank you. Appreciate it. But there's a lot of stuff. There's a lot of stuff to consider. Just learned implementing batching the other day. Machine learning is so fun, isn't it? The awesome dude guy. Thank you for the likes. It is. It's really cool. And we won't have time, but we will do this later today. We will. Later today, we will start doing batching because we need it for the MNIST training set because it's just too big. It's just too big, you guys, so we have to do batching. We have to. Mr. Lamb, I wish of the day of PubNub goes public LTD. Yes, that's the idea. That's going to happen. You have bragged so much about the being the top contender. We are number one in the comms sector. We already have 1 billion connected devices. You've already used PubNub. You've already used my company and my technology, and you didn't even know it. Isn't that crazy? You probably already have apps that are installed on your phone right now the second that use it. You have TVs, maybe a television that's using it now. It's so cool. It's so great. I love it. Learning reinforcement learning, ATM, having fun coding, reinforcement learning. There you go. That's the good one. That is the good one. Thank you for all the likes, you guys. Would love to evaluate P&L appropriation and the balance sheet of your firm. Mr. Lamb, yep, there you go. I was thinking about that. Yeah, we keep that data private because we want to be able to have a big impact when we're approaching investors. And so obviously when we're approaching investors, we want to be able to show that we've got a really good outcome and we can set it up that way. And we've done that many times in the past, and we've been very successful. That's why we've, raised over $140 million, you guys. That's a lot of money. Oh, so much money. Yep. And then we're making, and we're a profitable company. And so we're doing good things. We're doing good things, you guys. We're making our ways. We're making it happen. Thanks for the ideas. Excellent. And plus the recent lies that have been tested in the research where AI blackmailed an employee and whatever. The tech man, we do have to be careful, don't we? We do have to be careful. We have to be careful, you guys. Okay, let's see here. Let me see. The MNIST, I misagree with the statement, sir. Mr. Lamb, I don't think AI will take over the repetitive and monotonous stuff, but it could never do what humans can, and there will be demand for engineering. You're right. So here's the deal. Mr. Lamb, you're right, because the existing AI models today, they don't have any ambitions, desires, drives, or motivations. There's none of that. That does not exist. They're just sort of a tool or a machine that can do pattern repetition. It can do pattern repetition. Most of our day job involves pattern repetition. I would say a pattern occurs and then something needs to happen because of that pattern, and then another pattern needs to be applied. These machine learning models, these AIs, they can do that very well. They even do it better than humans in that many cases. So they're good at the pattern repetition part, but from the human perspective, they don't have the ambitions or drives or aspirations or desires. So they won't be able to take over in that aspect. Hot Ice, hey, how's it going, Hot Ice? Wait, Cosmocrat. Hey, Cosmocrat. Great Pythonista. Great Pythonista. Does typing code bother you? I actually enjoy it because that's how I learned it. I think that's a really good way to learn. Cosmocrat. Haras. Okay, what are you doing? Last time I visited. Oh, here you were doing deep learning. That's what we're doing. We have a bug and we're trying to fix it. I don't know if we can fix it. I'm not sure if we can fix it, but I'm trying to get all the chat messages here. I got too motivated. You did with your talks, and I continued with my Spring Framework Java. Okay, you got some Java JVM there. Very cool. Excellent. Pet Tarantula, you got it. Apex. Hey, Apex, how's it going? 3744. Good to see you in here again. Cosmocrat. In the program, remember that you do not produce material values. Oh, all right. It's just work. You're right. It's not material. It's just work. Dracula. Whoa, we got a famous person in the chat. Dracula is here, you guys. If you're reading chat, can you please give a college freshman a roadmap to actually learning machine learning? Yes. I recommend starting with Keras, MNIST, TensorFlow. There we go. Start with this. And I think this is the one here. This is a really good starting point. All right, start here. I think this is a really good starting point because what it does is it teaches you computer vision, and it teaches you how to use Python, and it teaches you all at the same time how to build AI. And just follow the instructions. It's okay. When I did this, I didn't know what I was doing. Actually, this didn't exist. When this right here up here, this didn't exist when I was learning. So you actually have a much better time learning than I will. I think this is a really good entry point. It's a really good, hey, Quantified Quantum, how's it going? Welcome on in. Dracula, I hope that helps. That's a good starting point here. It's called Keras, MNIST, TensorFlow. I think it's a good starting point. Good starting point. Did Blum just give out numerical benchmarks instead of being vague with his company's records? Yes, Mr. Lamb, that's actually public information because of filing. But we did, you can see us on Crunchbase. So you can see PubNub Crunchbase. There we go. You can see where we've been and where we're at. Oh, we got to verify. 1 second. We're humans. We're humans here. And then you can see our data and our funding and all that stuff. So okay. Here it says here's our funding right here. There you go. Lots of funding. But yeah, we're profitable. We are doing good. We're doing good. Whoa, we got a phone number. Look at that. Okay, I do have to get going. I'm noticing that we are starting to get back to. I do have to get going. But hey, that's me. That's from me a long time ago. Look, here's a picture of me. It's from a while ago. That's crazy. What do you know? That's crazy. Yes, I did. What do you? Why do you do YouTube? The Tech Man. The Tech because it's fun. It's so much fun. I love it. It's one of my favorite things. I just found out just by doing it and trying it. I really like it. And we're doing good on the numbers too. We're doing good. We're getting started. What you build? Oh, STFU. Okay, so we are building a machine learning model from scratch is what we're doing. Machine learning model from scratch. That's what we're doing today. But we have a bug, and I actually have to get going. I'm noticing that people are starting to come back, so we have to. I might have to get going here pretty soon, but not yet. This here might come off as offensive, but what is your favorite hoodie? Oh, this one right here. It actually, you can see, it's got my company name on it. Like I said, it's the best hoodie I have. It's really comfortable. I don't know where it came from, but it's really good. Okay, Quantified Quantum. Like the video, everyone. And good to see you, Quantified Quantum. We'll be back later today. What is you've seen anything else for months? Yeah, this is what I wear. But I've got like another shirt underneath. Oh, what do you know? It's another company logo. I don't have to buy any clothes. It's great. It's great. All right. Rushil, I'm building an AI for a company I work for. Excellent. I'm using OpenAI, APIs, SDK, and Pinecone for vector database. I can get to work, kind of, but I'm on the right track. Well, here's the problem. You're using a vector for semantic similarity search, probably. What are you doing? You probably might not need that. Might not necessarily. You might want to just use standard keyword search. You might not need semantic. It really depends on what you're building. You could just do SQL full text search. SQLite full text search. You probably do better. Tomas, deployed my first single web page. Did you? At work today? A forecasting tool. Bosses were blown away. They were, Tomas. That's so cool. Good job, Tomas. That's amazing. That's really cool. That's a good milestone. Flaming Corgi, I gotta go. My Wi-Fi is slowing down and YouTube isn't working so well. Oh no! Oh no, Flaming Corgis. I have to get going here in a little bit, but it looks like we do have a little bit of time, so we're okay for now. What are we making, Epic Films? We made our own machine learning language from scratch, or our own framework from scratch. Our very own machine learning language from scratch. So it's actually right here on the screen. The main algorithms are right here, and it's just these. These are the most important parts to machine learning. And deep learning, you guys, we built it. We did it. And we were successful on stream. And now we're using it, and we're testing it out. We're giving it a test drive. But there's a bug right here. There's a bug. Let's see here. Let's see if I can show you where the bug is. Right here, as you can see, there's a bug. Divide by 0. It's a warning. It doesn't matter because it actually the training actually works perfectly fine. But I would like to figure out where the problem is. If we could figure it out, I would love to. It says there's a divide by 0 encountered in a matrix multiplication. How do you even do that? How is there a divide 0 in a matrix multiplication? I don't know. Honestly, I thought hearing pubnub was related to the pub. Oh yes, that is an often a miscommunication. You're right, the tech man, the pub. It is. It's often. When I did my final project, Muhammad was focused on converting ASL and ISL into text and audio to bridge the communication gap between signers and non-signers. That's a really cool idea. That's a computer vision task, Muhammad. That's a really good idea. Nice idea. Good call. I like it. I'm just looking at here on my meetings. I might have to get going pretty soon. We have a few minutes, it looks like. Got a few minutes. Okay. Can we build an app with Python? Lamb, you got it. We could totally. Why not? We could build anything with Python. I spent a lot of time preparing the data set and performing annotations. That's the best way to do it. That's the best way to do it, you guys. Okay, I do have to get going. I actually have to get going here. One second. I have to go. Looks like good. We got to get going. Thank you guys. Thank you guys for hanging out. I do have to get going. It was great to see you. What is your name? Epic Films? What is its name? What do you mean? What is this? Oh, this. Okay, Spider. Okay. Thank you for joining. I will be back later today. YouTube wants me to watch you. Really, yummers? Okay. But we have to get going. Thank you guys for hanging out. We're headed back to regular job. Are you an AI expert? I would like to say I like to do AI. I like to do AI, and I can figure it out. I can figure it out enough, and we're working together. So, real quick. So, is it the company info speed process within the company basically getting information faster? Yes, much faster. Thank you guys. Thank you guys for seeing. I gotta go. It was good to see you guys. I have to click the stop button now and join my other meeting. See you guys. We'll be back later today. Bye, guys. Bye, everyone.